Hello, good afternoon, everybody. Thank you very much for attending this conference. The main goal of this conference is to explain how we have integrate our system with the Microsoft Azure cloud platform. But before that, I would like to introduce to you our company and what we do, because at the end, this is the result. When we are sending data to Microsoft Azure, I would like to explain to you where this data comes from. So, okay, you present to me. My name is Laín, and I'm the IT manager of Libelium. I'm responsible of the Meshlium device who is connecting to the Microsoft Azure cloud platform. So the success of Libelium is based on this device. Libelium is a very young company. It's only 7 years ago when my two people start developing this device. They were David Gascon and Alicia Sin, the owners of the company. And 7 years ago, they start thinking on Internet of Things, how to gather different data from many sensors. And from that point to now, we have invested much resources in research, and this is the product that we have got in this time. And this product, the success of this product is that we can connect many different kind of sensors, and we have at the same time radio communications to send this data to whatever. Nowadays we all talk about the cloud paradigm, but it means servers, databases, and whatever. So this is what we have got with this device. It's a microprocessor power device where we have many digital inputs, and we can send. We need to process this data to discretize the values, and then sending these values to the cloud or whatever we want. Based on this device, I can talk about what can we do with this. And this picture is very representative that we can do almost everything in terms of sensing data, I mean. Because this device that I have showed to you is like an horizontal platform that can be used to any solution that you may need. So that's one thing that is very powerful on our solution as well, because before this, what we used to see in the market were very specialized solutions, where you have got a closed solution for, let's say, sensing the quality of the air, for example. And then if you want to do another solution for sensing the humidity, let's say, you have closed solution. With our platform, it's open to give and to develop solutions for any kind of need you may need to solve. And here is a very good picture, because moreover, nowadays the term of Internet of Things is getting in all the news and so on. But 7 years ago was not very known, this concept of Internet of Things. And at that point, we were starting to work on this, that they were called wireless sensor networks. But at the end, it's the same point. It's sensing data, gathering data from many different sources, and collecting to do and to develop solutions in this, let's say, market of smart cities, smart agriculture, and I will show later some of those applications that we have done. Yes, this is as well a good picture to show what the device gets. In the left, we can see any sensor. So this device can connect any kind of sensors through any kind of protocol to any kind of cloud platform. So this is, when we say any sensor, I mean that we are working with manufacturers of the sensors. I mean the galgs and the component, the device. And there are many manufacturers that do this kind of sensors of any sort you can imagine. And we are in contact with manufacturers to connect those sensors to our Waspmote device with some digital inputs. Then there is a microprocessor that we program and how to discretize this data and get the value at the end. On the other layer, we have the radios that we are also working with manufacturers of all of those different radios to implement the communication protocols. And once we get the value and when we have implemented the communication protocol, we can send this data to the cloud or any server to store and analyze this data. Okay, this is just a list of the sort of sensors, the different sensors that we can connect to the Waspmote device. As you see, it's a wide list, and it's growing. It's always a dynamic list. We talk with different manufacturers for the same kind of sensor, and we are continually improving. And we also have different. You can use different sensors to measure the same value, depending on how much reliability you need and so on. So you can configure very different applications based on your needs and on your requirements. There are some more examples that I will explain to you now in real examples on how we have used all of those sensors. Two main features that I would like to talk about the Waspmote device are, one is the low power feature, that we have got a very good rate of power consumption, and those devices, most of them are installed using a solar board, so we can charge the battery and a bigger rate than the battery is consumed. So one of those devices the lifetime of the devices is more based on the components, that the life of the components, because the battery maintains growing in time because of those good algorithms for keeping the consumption of the battery very low rates. We put the device in sleep mode. In a very good, we have a very good algorithm to get the device most of the time in sleep mode, so we get a very good lifetime of the device. And another one is the distance that using the low frequencies, because on those radios that we use to implement the protocols for communicate the data from the Waspmote to the clouds, we are using low-level frequencies. We are not in the 2.4 gigahertz frequency, but we are using in the megahertz 868 megahertz frequencies and around that. So we have done this test. This is here in Zaragoza, and this is with no buildings in the middle. I mean, it's a test in 2 points with direct point of view between them. But we test as well in the city, and we go from the 21 kilometers to 2 or 3 kilometers rate. That we have done this test using these low frequency radios. So those two features make this device very good to be a very good device to solve the kind of applications that we are talking about: smart cities, smart agriculture, and so on. Okay, and this, then we have this. I showed to you the device, let's say the core, the platform. I want to say as well that it's an open platform. We provide the APIs to program these Waspmote nodes. So the hardware is not open hardware, but we provide all the libraries, the SDK, and everybody can buy the device and program, focusing on their very own special needs. Once we get this, we put everything into a box, and here you can see how it's sold. With the solar panel to charge the battery, and those devices are totally autonomous. You mean we have installations in many cities for agriculture in the fields in the middle, and they have the autonomy. And it's totally locked, so the device is safe inside to be outdoors. This is the whole line of the professional line of devices that we have using this open platform. And we have many verticals that we provide the solution. I mean, this is an open platform that in some cases the client has they know how to program the devices and can develop a special application for their needs. But for some solutions that the client doesn't need to program it, we have special verticals solved for smart cities, smart agriculture, smart parking, smart water, and many solutions that we have already identified that is growing the needs of this solution, and we have this line of products already prepared for selling. This is an example. In the USA, there are some for doing wine that we can measure the humidity and the amount of water that the plant is getting, and this data helps very much to the agriculture to know the quality of the wine and so on. And this is an already installation already done in the USA. As well, we have some applications to control the data that is being gathered. Another vertical that we have implemented as well in Santander, in a city here in Spain, is SmartParking, that we have another device that we put under ground and detects when a car parks over that and gives information to the users on which street they have free parking or which streets are full. So when they are searching for a free parking, this can help to them and can avoid traffic jams and so on. So that's another application already done. About water, this is a new concept that, as well as smart cities, is very known, and we have listened more about smart cities, and we know that the concept of taking data about the quality of the air and so on. Smart water is quite new, but this is something that we detect that we will be more demanding in the future to measure the quality of the water in the rivers and detect possible contamination and so on. So this is another product that is quite new of the others. Another example that I would like to show is about radiation. Not far away, last year, I think, or 2 years ago, when the problem with Fukushima, with the nuclear central, we build with the Waspmote. We take a Jaeger tube and we do a sensor to measure the radiation, and we send to Japan some of those devices. In a first time, we did 100 or 150. And when they got there, very soon they were requiring some more, because it was an easy way, so everybody could be sure the amount of radiation that they will be receiving, and they don't need to wait for the official data or whatever, and was very demanding and was very helpful. As well, those devices could be assembled, and from helicopters they launch, let's say, the device, and there were no risk for any people taking the measure. So they could locate and launch the devices in the area with the problem, and they could receive the data with putting no person in risk. So that was another success case for using our technology. This was the device that we did at the first time. Like something different, because smart cities and other applications that are widely used and very demand, we as well do some projects that are more interesting, but not so commercial. And as well, we use our device to detect combustion levels in some forests in summer, to try to detect very soon if could be a fire in the forest. So this is another interesting sort of projects that could be tackled with this technology. So it's very, very open, and all of those needs will be arising more and more in the future. Something that we feel proud of is when we put one of our devices in the ArduSat. It's an open source satellite that was launched to space in 2013, and the development that we have done for this Fukushima problem, we put here the Jaeger tube to measure the radiation that comes from solar storms and so on. And we put that device in this ArduSat satellite, that is an open source satellite, and it's another project that we would like to show, because it's very interesting for us to put our technology into space. Sorry?
Does your device talk directly to the Earth?
No. I will go through that later. Now I'm talking about the devices that use this earthy technology, and I will talk later how we gather this information. So now I have talked to let's say, the Libelium main division, that we provide these kind of solutions for big projects, let's say in the cities, countries, and large-scale projects. But as well, Libelium, we have another division, let's say it's more for makers. As I told you, this Waspmote device is an open platform, and we provide the APIs and SDK and so on. And we use this device for our plug and sense line of products that I show you, with the concrete verticals, smart cities, smart agriculture, and so on. But we have a line as well that we call cooking hacks, where what we do is to provide information to any people interested in developing this kind of solutions with a very complete and detailed tutorials on how to build these solutions. In this area, we did this e-health sensor platform that is not really a medical device, because for getting a device getting the medical market, you need to pass very much certifications, and it's not easy. But it's not a medical device, but it's just like a lab or a kit to start going in that direction. Moreover, in many countries that they don't have access for professional medical devices, they are using this device because this device has not the levels of tolerance that are needed to be a medical device. But for some countries where they don't have access to those devices, this is good enough. In fact, they told to us that it's much better than having nothing. So this that was built at the beginning like an experiment in a maker way. At the end, it has been useful as well in some areas. So this is another thing that we think that the open platform helps to take the technology to places where it's not easy or they don't have easy access to technology. So making open platforms and open protocols helps to go there. This is just an example or how this device is connected and gets data. Okay, another example of those in this maker area that we have is Open Garden. That is as well another device that we provide the tutorial and how you can do on your house. That is getting as well, like it's a growing fashion to build these ecosystems with the fishes and the plants getting it's called Aeroponics. So we have this device as well. Not the device, because as I told you, what we do is a tutorial and how the instructions how to use or how to build this device using the Waspmote and the other technology. Other example is the Open Aquarium. That is quite common to have those hot water aquarium, and you can build this to feed the fishes. Even if you are not at home, you can feed the fishes from your cellular or so, and it's quite interesting. So people that likes to build this kind of solutions, we provide the tutorial as well and all the steps to be taken to get this working. And now, related to your question, this is the Meshlium device, and here is where the connection with the cloud start to get sense, let's say. For Libelium, what we do is to collect all the data gathered for those devices that I showed you before. That is the main core of our solution. And they send the data to this gateway device. Let's say that those devices are using the low range frequencies for a communications protocol, and we can measure, or we have measured that 2 or 3 kilometers with buildings are 21 kilometers. So when we have an installation in cities or fields for agriculture, what we do is to install one of those Meshlium to gather all the data from the Waspmote device or Plug and Sense device. And the Meshlium device is who has a 3G connection or Wi-Fi connection to internet, and this device gathers all the data from those devices, stores the data in a local database, and can publish this data in the cloud. This is the picture what I explained to you. We can see different mesh network of Waspmote devices sending the data to Meshlium. Meshlium is a Linux, an embedded Linux, and has its own database and all the facilities that the Linux platform provide. So all the data gathered is stored in a MySQL database in this gateway, and the device has Ethernet, Wi-Fi, and 3G communications possibilities. So those are three ways we can connect to the World Wide Web and to send data to external databases or third-party cloud platforms. Some partners we are already working with are those that you can see here. We have implemented MQTT protocol with Telefonica. We have implemented as well a protocol they have for sending data to their platform. Esri is a well-known GIS platform, and we can locate the Waspmote and the Meshlium device in a map. So in some installations, we can go through the map to a concrete node, and clicking on that node, we will see the values of the data that is measuring that device. Axeda and ThinkWorks, we are working closely with them as well, because Libelium is providing this kind of solutions worldwide. I mean, we sell our products moreover than 80 countries, and ThinkWorks and Axeda are worldwide extended and are well known, and many customers require to gather and to collect this data into those cloud platforms. And what we will talk deeply later is about how we as well integrate with Microsoft Azure cloud platform. So yes, I think that this picture is really descriptive about how we get the data and how we send to the platform. I won't go in detail about what Meshlium is. I told you it's an embedded Linux. It's a powerful machine. It's not like the Waspmote device that is not very powerful microprocessor, which just needs to read the data and send to the protocol communication. But Meshlium is a powerful machine where we have many possibilities. One good point of this device is that we have four possibilities of communications radio at the same time with Wi-Fi, 3G, Bluetooth, and Zigbee. This device is collecting the data of the Waspmote, but has as well, sometimes it's used as, we have a configuration of this device that is called Meshlium scanner. And what we do is to gather all the cellulars or the Wi-Fi devices that are around the Meshlium, and as well the Bluetooth device. And this is used as well in some places to trying to track how many people is getting inside and or is going outside a venue or a mall. Sometimes we have installed there. Okay, just to show to you a little bit how Meshlium is managed. We have a very simple interface. It's a web interface programmed in PHP. It's like a very simple management interface. And here we can configure different features of the Meshlium, like the interfaces, the Wi-Fi access point parameters, database parameters, and one of them that we will see is the cloud connector configuration that is needed, so any client can connect the Meshlium with their credentials to the cloud platforms. Here, what we can see is how the data of those Waspmotes is stored in the database. Here we can see the timestamp. We have an ID for any node of the gathering data, or one of Wasp ID, and the type of frame and the value at the end of that is being read by the device. I will talk to you about the different types of frames that are sent later when I will explain how we connect or send this data to the Microsoft Azure cloud platform. And here as well, you can see how is the frames. That this is something that we have defined, is defined by Libelium. So all the Waspmote send the data in this sort of frames. So the Meshlium has already implemented, has an agent that is reading all of these frames and is, let's say, getting different fields and storing in the database in the right way. So after that, all the data could be exported to another applications. This is what I'm talking to you about, is the how to do this. As well as we provide all the tools with Meshlium is the same. Meshlium has its very own database locally, but you can create this table in your another database in your server, and if you create a table with these values, you can store the data of those devices in your very own database as well. We have a process into the Meshlium that synchronize the local database with the other database that you may have on your very own server. As well, what we have defined is all here is just an example, but we have a long list of different sensors. As I showed to you in the second slide, that were sensor for gases, for humidity, temperature, the Jaeger to 100. We have identified all of them. So we have a fixed list that is growing day by day. We are improving it, but we have defined this as well. So when we send the data from the Waspmote to the Meshlium with this special frame type, one of the fields is the sensor ID. So Meshlium knows exactly what kind of sensor is the data coming from. As well, as I told you, an open platform. Is some customer has a sensor that is not in our list. It's possible to connect and to program the code adding another ID, so you can manage your very own sensors as well with our platform. It's possible to implement new sensors, not yet implemented by us. Okay, and now going to the how we send this data to Azure Bus. In fact, it's quite easy with all of this platform done. At this point, we have all the data in our database, so it's in all our experience in integrating different cloud platforms with our devices. Most of cases, it's very easy because we have the data in a database, and the cloud platforms, most of them provide libraries and or use an HTTP REST protocol, and it's quite easy. In this case, for Azure, what you may need first is to get a namespace in the Azure portal. You log in there, and you need to define a namespace. and use get some credentials. In this case, Microsoft Azure. Sorry. Ah, okay. Yes, I'm finishing. Okay, you get the namespace in Microsoft Azure portal using these credentials. We will configure in the Meshlium the credentials to send the data. And we have developed a Java agent, let's say. We call agents to the programs that are running into the Meshlium, and those agents are sending data to the different clouds. As well, we identify which one of them have already sent the data with some flags. So this could be possible for all of them. In this case, this is just an example on how we connect to the service bus. I forgot, in Microsoft Azure, what we are using the service bus facility, okay? And we will send queues. This is the configuration in the Meshlium for the Microsoft Azure agent, and you just need those credentials, the namespace, service owner, and the service key. You configure here, save these parameters, start the agent, and you start receiving data in the queues configured. What we need to do is to create the queues in your namespace. We have to create different queues with the Waspmote IDs, so we don't create many times. And this is very useful as well, because you can subscribe to only read data from one node. You don't need to receive all the data. And this is how we send the data, with this agent publishing data into these queues. We read data from the database that I told you how it's defined. And what we do is to create a JSON file with the data. And what we publish in the Microsoft Service Bus queue is this JSON message, one for each data that is read. Okay. Okay. So when the agent starts running, we read data from the database, we create this JSON message, and we publish in the Service Bus queue for that Waspmote ID. And once the data is getting there, then you only need to develop the client that is reading this data. You register to the queue that you need, and you can build a graphic or a web application, whatever you want, using all the facilities that the Service Bus facility provides to you. This is just an example when we were doing the integration that shows that the data is getting into the Azure platform. This is not the data itself, but it's just showing to us that we were receiving messages. Okay, and that's all. This is what we do here, and how we have integrate our Internet of Things devices and all the sensing data with the Microsoft Azure platform. Any questions or whatever? Yes.
Which Linux distribution do you use?
Sorry?
Which Linux distribution do you use?
In that case, it's specifically for the board use. That is a Voyage Linux distribution. That is specifically done for that board that is powering the Meshlium device.
Is it basically the same information that you store in the local database and information that you store in the public cloud, or do you have cases in which some of the information is only stored locally, maybe for security or confidentiality issues, and only some of it's actually uploaded to the public cloud?
No, in fact, all it's the same. It's the same information.
Okay, so it's like a replication for backup, right?
Sorry.
It's like a replication of the same information for backup.
In fact, maybe I didn't go deep enough. Once we get all the information in this local database, we have different facilities to publish this data. One that I talked is syncing to synchronize the database in an external database. That could be used for like a backup, let's say, but as well you can have your very own applications reading data from your external database, and you can do whatever. As well, you can integrate with MQTT, with ThingWorks, Acceda, Esri. Any of these platforms is for example, the Esri is focused in showing the nodes in a map, so you can locate them in a map. The external database could be focused for backup. Meshlium Azure could be focused for building graphics, so any of them has its special role.
I understand. Yes.
Okay. But you can publish in all of them, and as well, this is again open. I mean, we can suggest to do this for this purpose, but you may find another use using the same technology. Okay, thank you very much.